Have you ever looked at your AI bill and just winced? Well, today we're going to show you how to build a really smart system that can slash those costs without, and this is the important part, without sacrificing quality. We're going to create a custom router that knows exactly when to use a big, powerful model and when a cheaper one will do just fine.
Let's just start with this idea right here, because it gets right to the heart of a massive and honestly wasteful problem in AI today. Every time you send a super simple query to a top-tier model like GPT-4o, you're paying a premium for something a much cheaper model could have handled perfectly. It is literally like hiring a Michelin star chef just to make you a piece of toast.
I mean, just look at these two queries. On the left, you've got a simple name extraction. Easy. On the right, a complex legal analysis. Now, should those two things cost you the same amount of money to process? Of course not. But the problem is, a lot of systems treat them exactly the same, just throwing the most powerful and most expensive model they have at everything. This one-size-fits-all approach is just a huge drain on resources.
So this mismatch between how hard a task is and how much a model costs, that is the exact problem we are solving today. And the solution is a really cool concept called an LLM router.
The best way to think about it is like a smart traffic cop for all your AI requests. So instead of one giant congested highway where everyone pays the same toll, the router looks at each query as it comes in and directs it to the best possible route. Simple tasks, they get the express lane with a fast, cheap model. The really complex stuff gets sent down the premium route to the more powerful one. It's all about making things dynamic and cost-effective.
Now, this is all powered by something called predictive routing. And this is really the secret sauce that makes the whole system work. The key word here is predictive. The router makes its decision based only on the question you ask it before you spend any money generating the answer. This is so important because it avoids that really costly mistake of trying the cheap model, failing, and then having to pay for the expensive one anyway. You make the right call right from the start.
Okay, so let's get into the weeds a little bit. Building one sounds kind of complicated, right? But the core idea, which you can see in great tutorials like Annie Scale's RouteLLM, can actually be broken down into 4 pretty clear steps.
So how do you actually build this thing? Well, here's the game plan. First, you create a data set. You just take a bunch of sample questions and run them through both your cheap model, say Llama-8B, and your expensive one, like GPT-4. Step 2, you use that powerful model, GPT-4, to act as a judge and score how well the cheap model did. Pretty clever, right? Now you've got a labeled data set. And finally, you use all that data to train a small, super efficient model whose only job is to predict how well the cheap model will do on any new question.
And here's where the magic happens. When a new query comes in, this tiny, fast router model just takes a quick look. If it predicts a high score, say a 4 or 5, it knows the cheap model can handle it and sends it right over. If it predicts a low score, it knows to escalate to the big guns. And this all happens in a fraction of a second before you spend a single cent on the actual answer. So, the theory sounds fantastic, but does this actually work in the real world? Let's dive into the data and see what kind of impact we're really talking about here. You bet it does. Check this out. The code-dining paper, which looked specifically at complex coding tasks, found that a well-trained router could slash API costs by an average of 43%. And here's the best part. It did that while maintaining the exact same level of quality as just using the strongest, most expensive model for every single task. That's a huge win. And this table really just paints the perfect picture. Look at that top line. Use the strongest model for everything. You get great quality, but at full cost. Try to just randomly split traffic? Well, it's cheaper, but your quality takes a nosedive. But then look at the LLM router line. You get almost the exact same quality as the best model, for nearly half the cost. It's the best of both worlds, and it gets you remarkably close to what a perfect, all-knowing Oracle router could achieve. So we've seen the data, and it's pretty clear that these routers are an amazing tool for saving money. But this is more than just a clever trick. This is actually a practical application of a much, much bigger idea in AI that's really shaping the future of the whole field.
And that big idea is called Mixture of Experts, or MoE for short. Think of it like a team of specialists. Instead of having one generalist who tries to do everything, you've got a whole team of experts, each with their own unique skills. And when a new task comes in, you only call on the 1 or 2 experts who are perfect for that job. This is exactly how cutting-edge models work, and it's a way more efficient way to build AI.
And this is the brilliant connection. The LLM router we've just been talking about
It's basically a manual mixture of experts. Instead of routing between tiny networks inside one giant model, you're routing between completely separate large language models. But the principle is identical. Don't use the whole system for every single task. Just use the right tool for the job.
So, what's the bottom line here? LLM routers are a super powerful and practical way to make your AI smarter and way cheaper. They can slash your costs, they protect your quality, and as we saw, there's something you can actually build. This isn't just about saving a few bucks, it's about building a more efficient and sustainable future for AI.
And that really just leaves us with one final thought. As AI gets more and more powerful and woven into everything we do, the cost, both in money and in computing power, is going to be a huge deal. So maybe, just maybe, the smartest AI isn't the one with the most power, but the one that knows when not to use it.